Right now, far beyond Earth's skies, something extraordinary is unfolding. On July 1st, 2025, a faint dot appeared in images from the Atlas Survey telescope in Chile. At first, astronomers thought it was just another minor object, drifting quietly among the countless asteroids catalogued each week. But this one was different. Its speed told the story. It was moving at a blistering 137,000 miles per hour, about 61 kilometers per second, on a hyperbolic path, meaning it wasn't bound to the sun. Within a day, astronomers confirmed the unthinkable. This was only the third interstellar object ever discovered. They named it 3I Atlas. And ever since, the comet has been refusing to behave like anything we've ever seen before. It's glowing, flaring, and shifting in ways that defy prediction. And as it approaches its closest point to the sun, just inside the orbit of Mars, scientists admit, this visitor could be about to do something unexpected. Stay with me, because in the next few minutes you'll see the shocking way 3I Atlas is defying comet science, brightening and flaring in irregular bursts. The green glow mystery, why it shines in ways that don't fully match known chemistry. Its uncertain size and fragility, and what could happen if it fragments. The Mars pass and Sun encounter, key moments that could reveal its true nature. And the question scientists don't want to admit, could this object be more than just a comet? By the end of this journey, you'll understand why astronomers are calling 3I Atlas the most unpredictable interstellar visitor we've ever seen. At the moment of discovery on July 1st, 2025, the comet was about magnitude 18.0. In astronomy, brightness is measured on a reverse scale. Higher numbers mean fainter objects, so Mag 18.0 is extremely faint. Detecting it required powerful telescopes and careful image processing. Astronomers expected a typical path, a slow brightening as it neared the sun, following the predictable curve seen in comets countless times before. But 3I Atlas had other plans. By late 2025, it was observed around magnitude 12 to 13, hundreds of times brighter than its discovery level. That's not just unusual, that's extraordinary. For comparison, 2I Borisov, the second interstellar object, brightened gradually in line with models. 3I Atlas has instead been leaping forward, then stalling, then leaping again, like a cosmic heartbeat no one understands. This was the first sign that the comet is not one that plays by the rules. Normal comets follow a simple script. Frozen ices near their surface sublimate as sunlight warms them, releasing gas and dust. This forms the glowing coma and the iconic tail that sweeps across the sky. But 3I Atlas rejected this script. It clearly has a coma, but its brightness variations have been irregular, short flares and slowdowns rather than a steady rise. That's not how comets usually behave. Then came the outbursts. Instead of steady brightening, the object would suddenly flare, then fade back again. It behaved less like a stable comet and more like a cosmic flare gun, throwing bursts of light into the dark. Astronomers tried to fit these surges into known comet models, but the data refused to comply. It wasn't the slow boiling of ice. It was chaotic, uneven, and unpredictable. It was as if something deep inside 3I Atlas was struggling to break free.
We've got some fresh images of 3I Atlas, a third ever interstellar object observed from Earth, currently racing through our solar system. Now, astronomers have captured that moment live, streaming in real time around the globe of them watching all of this. Take a look at this.
Things grew stranger when astronomers reported a greenish glow around 3I Atlas. On Earth, comets often glow green because of dicarbon molecules. Sunlight excites these fragile compounds, producing emerald fluorescence. But when the James Webb Space Telescope aimed its instruments at the comet, the results were surprising. JWST detected a coma dominated by carbon dioxide, with far less water than expected, along with CN and other molecules. CN is common in comets, but this CO2 to H2O ratio is unusual compared to typical solar system comets. This raises a mystery. If it's not dicarbon, what is causing the glow? Some expected volatile compounds like CN to be stripped away after millions of years in interstellar space. Yet here they were, venting intact. The best explanation is that the comet's nucleus shielded them until the sun's heat released them. Some astronomers suspect the answer lies in 3I Atlas's size and insulation. Early estimates suggested the nucleus might be enormous, but Hubble data placed the upper limit at about 5.6 kilometers wide, and it could be far smaller, possibly under a kilometer. For context, Oumuamua was about 100 to 200 meters. Borisov was roughly 500 meters. 3I Atlas is likely larger than both, but nowhere near 20 kilometers. This matters. A body even a few kilometers across can protect its inner layers from cosmic radiation. Its crust may act like a shield, preserving chemicals that smaller comets would have lost. That's why we may be seeing CN and other volatiles, material unchanged since its birth around another star. But that size also carries implications. A comet several kilometers wide traveling at over 210,000 kilometers per hour holds kinetic energy beyond comprehension. It poses no threat to Earth. It will never come closer than 1.8 astronomical units, but the fact that such massive visitors can pass through our system is a sobering reminder of cosmic vulnerability. Despite its size, 3I Atlas may be unstable. Comets are fragile, often compared to dirty snowballs or rubble piles loosely held together by gravity. As they heat, gas pressure builds within cracks and cavities. Too much pressure, and the nucleus can shatter like glass under strain. If the stresses grow too great, 3I Atlas could fragment into dozens of pieces, each on its own unpredictable course through the solar system. And if that happens, we'd be witnessing something no one has ever seen: the live disintegration of an interstellar object. One of the most anticipated moments comes on October 3rd, 2025, when 3I Atlas passes about 0.19 astronomical units, 30 million kilometers from Mars. For the first time in history, we may observe an interstellar object from another planet. ESA's Mars Express and ExoMars Trace Gas Orbiter plan to attempt spectroscopic observations, and NASA's Mars Reconnaissance Orbiter may also try imaging. The distances are too great for dramatic pictures, but valuable science could still be collected. There is no risk to Mars. No fragments are expected to hit the atmosphere, but any observations from orbiters would be a once-in-a-lifetime chance to see interstellar material from a new vantage point. 3I Atlas's most critical moment will come on October 30th, 2025, when it reaches perihelion, its closest pass to the Sun at about 1.4 astronomical units. At this distance, solar radiation is fierce. Most comets erupt in spectacular outgassing at this stage, their surfaces boiling and tails stretching for millions of kilometers. But this object is already flaring before reaching that point. What happens when it faces the Sun's full furnace? Some predict it could brighten to binocular or even naked eye visibility. Others fear catastrophic outgassing, where eruptions become so violent they tear the object apart completely.
The supposed comet is catching the attention of some of the nation's most renowned scientists, as one Harvard professor is raising the theory this may actually be a piece of alien technology.
The dramatic part. For several critical days at perihelion, 3I Atlas will be in solar conjunction, hidden behind the sun's glare from Earth's perspective. Our instruments will struggle to see it. If it fragments or changes, we may not know until it re-emerges. It's as if the universe has planned a curtain drop at the climax. 3I Atlas entered the solar system from the direction of Sagittarius, close to the galactic center. This coincidence sparked speculation about a possible connection to the famous WOW signal, although no scientific evidence supports such a link. Astronomer Avi Loeb has suggested, just as he did with Oumuamua, that 3I Atlas could be artificial. However, the overwhelming majority of scientists consider it a natural object, most likely a comet, and firmly reject the idea of it being a mothership. Even so, the comet's unusual chemistry and trajectory continue to fuel debate among scientists and the public alike. The timeline is remarkable. Before 2017, we had never confirmed a single interstellar object. By 2025, we've seen 3. This suggests our solar system is not isolated. We're part of a galactic traffic lane where fragments from other stars occasionally sweep through. If 3I Atlas is carrying pristine chemistry, it may even carry the ingredients of life. Some theories suggest interstellar comets could seed organic molecules across galaxies, scattering the building blocks of biology from star to star. Which means this comet isn't just a curiosity, it's a messenger, carrying material that could explain not just where it came from, but possibly how life began on worlds like ours. Over the next months, a global fleet of instruments will keep their eyes on 3I Atlas. The James Webb Space Telescope, Hubble, and major ground observatories will all contribute. ESA's JUICE and NASA's Psyche might attempt opportunistic measurements, but they are not primary observing missions. Yet despite this campaign, there's one thing no one can answer. What happens when the comet rounds the sun? It could fragment into glowing shards. It could blaze brighter than any comet in centuries. Or it could reveal something that forces us to rethink what interstellar visitors really are. 3I Atlas is racing toward its date with destiny. Every day, every flare, every chemical reading adds to the tension. Is it just a giant, unstable comet carrying chemistry from an alien star system? Or is it something more, something we don't yet understand? Whatever happens, 3I Atlas has already proven one thing. The universe is not empty, silent, or safe. Visitors from the stars arrive, and they don't always follow the rules we expect. The truth is this: in just weeks, this comet will show us what it really is. And humanity may never look at the night sky the same way again.